मधुकर आपका ऑडियो बंद है शायद. So have you started recording?
Yes, sir. I have started.
Good. Is my slide visible to all of you?
Yes, sir.
Yes, sir.
Thank you. Thank you. So today I will try to cover 5G core architecture. Let's see how much we are able to cover. So I have planned it to cover in 4 hours, 2 hours today and 2 hours tomorrow. So let's start. I have divided this into 4 parts. So the part 1, I'm starting 5G core architecture part 1. So in this part 1, I will try to cover high level 5G system, and then I'll talk about 5G reference point architecture. Then what is PDU session and QS flow. And then the key network function of 5G, that is access and mobility function, session management function, user plane function, policy control function, and verify data management. So for these 5 key functions, I'll be talking about what is their role in overall 5G network. So let's look at high level 5G system. So, and this diagram we have already seen in previous lectures. So now when we talk about user equipment here, so we are not only talking about mobile, but we are also talking about say drone, say autonomous car. So all object, all machine is now part of the user equipment. So that's why the icon of UV had changed. And then we have second part is the RAN, radio access network, next generation radio access network. If you recall, we have already covered nitty-gritty of NG RAN yesterday and day before yesterday. And then we have a 5G core network. Popularly, people call it 5GC. So 5GC is nothing but 5G core network. And then we have data network. Last time also I had discussed that why we call data network, whereas in 4G architecture, we used to call it PDN or packet data network. Can some of you recall why we are calling it data network and not PDN?
Sir, other than IP data, some other data can be realized.
Yeah, even unstructured data will be possible to be sent using a 5G network. And if you combine all, then we call it 5GS, 5G system. So whenever we say 5GS, so we are actually talking about end-to-end 5G network. If I just saying 5GC, I'm talking about 5G core network, and then of course RAN and data network. So 5G has got 2 types of architecture. One is called reference point architecture and other is called service-based architecture. So when we say reference point architecture, these are given in 3GPP specification document. So when we talk about reference point architecture, between any 2 node, like pair of node, there is a specific interface, like from AMF access and mobility function to unified data management. The name of interface is NET. Other example can be from SMF to AMF. So between these 2 pair, I have an interface of N11. And this is similar to what we had various interfaces in 4G, 3G, 2G. All were kind of a reference point architecture. But in 5G, we also have a service-based architecture in addition to reference point architecture, and most of the deployment of the 5G network is based on SBA, service-based architecture, and not a reference point architecture. But for the purpose of learning, we will talk about both. So let us first know the names of all the network function starting from UE. UE is user equipment. UE stands for user equipment. Then the RAN part. So RAN here we are calling it as a Z node B. So this is radio access network. And many times we say NG-RAN, next generation radio access network. And we also call it NR, new radio. So all different name for same thing. So it's a radio access network. Then we have AMF, access and mobility function. The full form of AMF is access and mobility function. Then we have SMF, session management function. And then we have UPF in the user data plane, which we call it user plane function, UPF. And this is the PCF, policy control function. And of course, this will connect to a data network. So any service or any server providing service, we call it data network. So connects to data network. There are many more network functions, but these are the key network function which we will try to cover in the part 1 of our session. So let's start with PDU session, the concept of PDU session and quality of service flow. What is a PDU session? So as you know, PDU session is like full form of PDU is protocol data unit. So PDU session means protocol data unit session. So basically what happens that there is some pipe created. So connection created from say user equipment to Z node B to UPF, and then beyond it goes to the data network. So this pipe series of connection is called PDU session, and this PDU session is used to carry user data. It used to carry user data. That means when we browse or when we say use YouTube and see the streaming, so all the data flows through this PDU session, this particular pipe. And this pipe is nothing but series of connection from UV to Z node B to UPF, and then it goes to the data network. In our case, it would be internet for YouTube or Netflix, or if it is a specific service, say AR/VR service or gaming service, it will connect to that. So this is the concept of PDU session in 5G. In 4G, I mean, this used to be called uh, uh, PDN connection. The name given was the PDN connection in 4G. Okay, so let's understand something more about the PDU session. So whenever a UV connects to the 5G network, I mean, after authentication, authorization, all those synchronization process, once it connects to the 5G network, a PDU session gets created for that user. One PDU session gets created for that user, and this PDU session will be unique for an user equipment. That means one PDU session will be meant for only one UV. This PDU session will not be shared with other UV. So that's why you say PDU sessions are unique to a particular user equipment. So now what happens that the granularity of any data flow is the QoS flow, right? So within the, let me erase the ink from here. So now what will happen that within this PDU session, a default QoS flow will be added. A default QoS flow will be added. And every QoS flow will have some ID. That ID we call it QFI. Quality of service flow ID. Quality of service flow ID. So that is to identify a QoS flow. So that means whenever a PDU session is created, a default QoS will be added. A default QoS flow will be added. So QoS flow is the lowest granularity within the 5G system for data user data flow. So that will get added, and that will remain. This QoS flow will remain for the lifetime of this PDU session. So once PDU session itself is terminated, this default QoS flow will also be terminated, but it will continue till PDU session exists. Now, now suppose a default QoS flow is added to a PDU session, as you can see in this picture, that one PDU session is added and it is default QoS flow. When we say default QoS flow, so this is some sort of best effort service, some sort of best effort QoS, quality of service. So this is not some sort of guaranteed bitrate type. It is non-guaranteed bitrate type of QoS flow, NGBR we call it. Now suppose the UE want to use a service which requires different kind of quality of service. Maybe if suppose it want to use a gaming service. So gaming service would definitely require high data rate and a good latency. So for that, a separate QoS flow will be added. And then suppose parallelly, the user equipment want to also do a voice call. So voice call also requires GBR, guaranteed bit rates, and also some other parameters of quality of service. So another QoS flow will be added. Okay. So what will happen that PDU session may have multiple QoS flow in addition to the default QoS flow. So required number of QoS flows will be added onto that PDU session, and each of these QoS flow, each of this QoS flow will be identified by its QFI. So quality of service flow ID. This is the identification, and within that, different quality of service will be managed as per the requested service. So this is the concept of PDU session and QoS flow. Any question till now before I proceed further? You can say yes or no, or please proceed.
Hello, sir.
Yeah.
Sir, are you just now explaining the start of conversation with the core network?
Yeah. So what I was explaining is like there are kind of there are two kind of data flow within the network. One is the user data. For example, if I am doing a YouTube or browsing, so the exact data which I am receiving or transmitting, and other is the control plane data for authentication, authorization, other management. So PDU session is created to support user plane data, which user data exists in the network. And I'm not talking about the control plane data. So after those authentication, authorization, if connection is already made, a UV is now connected and utilizing the service, that I mean scenario I was trying to explain, that how a PDU session gets created, how different QoS flow is added into the PDU session for different quality of service.
Sir, I have a
Sir,
question, sir.
Sir, one another question I am having. Can I ask in that
Yeah.
regard only?
Yeah, please.
Sir, is it related to the user data only, what we have talked? But before starting with the QoS flow or that PDU session to be established, we should have to go for authorization and
Correct.
verification of the user.
Correct.
So
Correct.
before that, some control plane activity has to be started, na sir?
Yes, yes. So for example, if you recall day before yesterday about the synchronization process, right? So the first thing when UV does is try to synchronize in time domain and frequency domain in the downlink direction. The second aspect is that it has to then synchronize with uplink direction. That is called RAS procedure. That also I little bit touched upon. So with that, uplink and downlink synchronization gets complete. And after that, the authentication process takes place. The UV has to prove its identity and authenticate. Even UV authenticate network, it's a mutual authentication. And then the authorization process, where it is checked that whether UV is authorized to use a particular service or not. So after all these, only this PDU session gets created. So you are right.
Sir, I have a
Thank you,
question,
sir.
sir. These
Yeah,
PDU
please.
sessions are unique to the user equipment, right, sir?
Correct.
Then if that be the case, so why do we need so many QoS in this PDU session?
So basically, suppose you are a user, okay? So you may be using multiple services simultaneously.
Yes,
So
sir.
for example, you are just browsing, you are onto the internet. So
Okay.
internet will not require a guaranteed QoS kind of. So you need only a best effort service. And suppose parallelly you are also gaming. So
Yes, sir.
gaming would require certain different quality of service, and maybe you are doing a voice call that will require a different quality of service. So set of services which requires a similar kind of quality of service will be given one QoS flow within that PDU session for that particular UV.
Anyway, having larger bandwidth, if you provide the highest quality of service for all the services, that will be better, no, sir?
So what you are trying to say that give him more resources and let him manage everything. But for example, suppose a particular service requires quality of service in the sense that suppose latency requirement is there, right? So
Yes,
to
sir.
achieve a better latency, generally the network will require to use higher numerology so that latency is better. I'm giving one example, right? And also the network which is having less coverage, small cell, so that your latency is better. So that's why the resources which gets allocated to you will be different compared to when you are browsing.
Yes, sir.
If I just give you enough resources of everything, it will be wastage of overall resources. Others may not be able to use effectively.
Yes, got it, sir. Thank you.
Thank you.
Yeah.
Okay, so let me
How many
proceed.
QoF session can be established for a user equipment? How many max?
So in terms of how many QoS flow can be added onto a PDU session, standard has not given any number. If you read the 3GPP document, so they have not given a specific number, but I suppose that I mean a user may not require more than 4 to 5. So it is up to the operator to configure. So as such, standards do not give any number, but practically operators will configure and limit it.
Okay.
And it also depends upon how many service one operator is offering. Today, if you look at our India network, so they are not offering any specific service as of now. If you see, they are just offering you internet, right? So they may not be using all these different QoS as of now. But for example, Jio would be offering a FWA service, fixed wireless access service, where they want to give you a higher speed of 1 Gbps. So they may have a different quality of service for those customers who would be using FWA as of now, and the customer who are just using their smartphone. So they may use two types of QoS flow as of now. Going forward, they may create certain use case for different applications. So they may use different quality of service. The third, which is already in use, is the voice service which we are using. Voice over LTE or voice over NR if that comes. So their requirement is of guaranteed bitrate, although the bitrate would be very less, but that has to be guaranteed. And on voice signaling, your packet error rate has to be 10 to the power minus, I think 4. So that is the requirement for handling the voice services. So you'll have a different QoS for voice services, different QoS for normal user who are using internet, and different QoS for say FWA. So there will be, as per the application being rolled out, operators would give different quality of service for different services. Am I clear? Should I proceed?
Yes, sir.
Thank you. Okay. So now we will try to understand the function of AMF, access and mobility function. Okay, so first of all, the AMF is a control plane network function. First of all, control plane network function. That means user data is not required to be handled by access and mobility function. And as the name suggests, access and mobility function. So sometimes we also call it core access and mobility function. If you know 4G, it is akin to MME, mobility management entity. Some of the function which MME was doing in 5G, it is being done by AMF. So as the name suggests, access and mobility function. So let's look at one by one. So as the name suggests, it is an access point for UE and mobility management. So when we say access point for UE, what I mean is that whenever user equipment connects to the core network, I'm talking about for control signaling, it has to connect to AMF. AMF is some sort of entry point for user equipment to interact with a 5G core. Control plane part of the 5G core. Of course, in between you have BTS or G node B, but it is kind of a transparent. It's a path for UE to interact with the 5G core. So this is an access point for UE. And of course, it does mobility management, which I'll talk about. The other thing is like it knows, AMF will know the location of the user equipment. AMF will know location. In what sense it will know? So suppose user equipment is active. When user equipment is active, AMF knows that user is in which cell. Cell ID of the BTSs it will be knowing. So it will know the cell ID where user equipment is active. In case user equipment is not active, if UV is not active, then AMF knows that user equipment is in a particular tracking area, TA. What is tracking area? Any one of you can tell me? What is tracking area? This concept was there in 2G, 3G, 4G, all Gs. The tracking area is kind of a cluster of cell. Cluster of cell. More, it is cluster of cell. Right. So, and for what purpose it is used? So suppose whenever there is a incoming call for a user equipment and user is not active, so AMF has to search that particular user equipment. So it searches by a method called paging, and that paging is done in the tracking area. User equipment is supposed to be there in the tracking area, because whenever it goes beyond tracking area, it has to update. We call it mobility update, and then its data is updated into the core network or AMF. So that way we can say that access and mobility function knows location of the user equipment, and that location would be either a cell ID if the user equipment is active, or the tracking area if the user equipment is not active at that moment. Then the third major function which it plays is authentication. As I said that UV entry point into the core network is AMF. So as far as UV is concerned, all the procedure related to authentication, AMF help in UV authentication. Of course, after AMF, you have AUSF authentication function server, and also the unified data management, which takes part in authentication process. But AMF plays a key role, being the access point for the user equipment. The next function of AMF is the ciphering and integrity protection. So for what purpose we do ciphering? Any guess? And for what purpose we do integrity protection? Any answer that what is the purpose of ciphering and integrity protection here?
So data security.
For data protection.
Right. So basically two things. One is that when UV is transmitting some data to AMF, or AMF is transmitting some data to UV, and these are control plane data as of now. So in that case, I mean, the data should be encrypted in the sense that even if somebody is able to intercept, since it is encrypted or ciphering done, nobody will be able to look at the data what it is. So it will look like a garbage for any intruder in between. So that is your ciphering. And then what is integrity protection? What is integrity protection?
Privacy is maintained, sir.
Privacy is maintained. So integrity protection is like your digital signature, right? So whatever you send, you also sign that, so that if any tampering happen in between, somebody tampers the data, the AMF will be able to understand that it is not the data sent by UV, it has been tampered. So, and the vice versa from AMF to UV also. So integrity protection is to know that if the data has been tampered on the way. So all the keys related to ciphering and integrity protection are passed on by AMF to the UV. I mean, both should know that what kind of encryption key has to be used for ciphering and integrity protections. So this is provided by AMF to UV. But of course, in the background, AMF will be working with AUSF and the UDM for this purpose, but the front end is the AMF for the UV. So that's ciphering and integrity protection. And then there is another function by which AMF provides temporary ID to UV. temporary ID to UE. So you may be knowing, are you aware about the IMSI which we have in our mobile? Whenever we buy a SIM card has got IMSI. You may be aware of, yes, no?
Yes, sir.
Yes,
sir.
great. So UV has to prove its identity to the network. So for that purpose, UV is required to send its ID, that is IMSI itself, to the AMF. In case of a 5G, there is a mechanism by which the UV IMSI gets encrypted and then only it is transmitted over the air so that nobody is able to capture. And this is new in 5G because this was not there in 4G or 3G. In some case, there were plain text transmission of the IMSI. In 5G, it is encrypted one. We call it SUKI. We'll talk about these later. Okay, but that is transmitted only once for the first time. For rest of the time, AMF provides a temporary ID to UE. AMF provides a temporary ID to UE, user equipment, and that is called GUTI. That is called GUTI. Do you know what is GUTI? Full form of GUTI? Any one of you who can tell full form of GUTI? Sorry. Any one of you want to tell me the full form of GUTI, please? So GUTI is nothing but globally unique temporary ID.
Identified.
Yeah, identifier. So AMF provides GUTI to UV and UV uses that GUTI while it is interacting with the 5G core network. So first time it will provide encryption version of IMSI, which is called SUKI, and later on it provides GUTI. And there are occasions on which different GUTI is provided by AMF to an UV. It's not a fixed one. This is not a fixed one. For example, whenever a user equipment does a mobility update, it will be provided a new GUTI. Whenever AMF does a periodic update, it will be provided a new GUTI. So every time this GUTI is changing, and this is to maintain privacy. So privacy comes here, that identity of the UV is maintained by first using the encrypted version of IMSI onto the air interface, and that too only once while UV is switched on, and later on UV uses GUTI to identify itself, which is provided by AMF. And finally, there is a role of AMF in lawful interception. As you know that in every country, there is a provision in the law that in case of some illegal activities are being done by one user, his call can be intercepted. So there has to be a certain requirement in the network by which we'll be able to provide those interception things. So AMF plays a helping role in lawful interception. One of the role played by AMF is the lawful interception. So any question on AMF, more question of AMF, or shall I proceed?
Sir, please proceed, sir.
Okay.
Can you, sir?
Yeah, please go ahead.
Can you just distinguish between SUKI and that GUTI once again?
Okay, so so three things you understand. Whenever we talk about IMSI, so this is the ID provided by the operators in the SIM itself. So this is your identity. This is not the mobile number. This is some different ID, which is ID of a connection, which is used in the network. This particular MC in 5G is called SUPI. 5G is called SUPI. So in 5G, SUPI can be MC and it can be some other things, which I'll talk about in another lecture. But this SUPI is never transmitted in plain text. So this is encrypted. This is encrypted. An encrypted version of SUPI is called SUKI. SUKI. This is subscription permanent identifier, and this is subscription concealed identifier, SUKI. So when UV switched on for the first time, it transmits SUKI to the AMF. Only for the first time. Next time onwards, AMF provides GUTI to UV, and UV uses GUTI to identify itself. Suppose it want to interact with the core, then it will provide the temporary ID, which is called GUTI, and not the SUKI or SUPI or MC. Is it clear?
Yes,
Is
sir.
it clear? Okay. Now, as I said, AMF also helps in mobility. So what is that mobility? Suppose a user is traveling. Suppose this user in a car is traveling and he is being served from one of the radio called G node B. So this is your source G node B. There is another G node B nearby, another tower nearby, and as you know, and the third tower nearby. These BTSs are connected to each other on an interface called XN interface. In 4G, this was known as X2 interface, if you know. In 5G, we call it XN interface. So this particular user equipment, when connected to, say, source G node B, but it keeps measuring the signal coming from other nearby G node B. So that is called RRC measurement, control and report. That means it is measuring the received signal from other cell and reporting to source G node B, right? Now the source G node B knows that how much signal strength UV is receiving from other G node B. So once it decides that a threshold has reached, that the signal coming from the source G node B is quite less compared to the signal coming from the other G node B, now that becomes a target G node B. So a handover decision will be taken by this node, source node. So it takes a handover decision, and then it interact on XN interface with the next G node B, where handover has to happen. So handover request and handover acknowledgement. At that point of time, handover trigger happens. So here comes the role of AMF, that now, as you know, that the data path. So data path is what? The data path is UV to Z node B to UPF, right? In this case, the data path is changing from one G node B to the next G node B. So data path from UPF has to switch like this. So this path switch request is done by the target node, and then AMF acknowledge that request, and this kind of handover process happens when you move from one BTS to other BTS. Okay, now let's look at the other network function called SMF, session management function. So AMF we have covered. Now we'll be talking about session
Sir,
management.
doubt.
Any question?
Sir.
Yeah.
Sir, in the previous this thing, you
Okay.
said UE will be getting will be knowing what is the signal strength from one G node B to another G node B.
So UV keeps monitoring all the signals coming from different G node B.
Okay.
And it will be reporting to the source G node B. So whatever UV have the information will be reporting to the source G node B where it is connected.
Okay.
Now the decision of handover is taken by the source G node B, knowing that signal strength from other BTS is quite more, have crossed the threshold. So based on that, it initiates the handover process.
Okay. Thank you, sir.
Okay, so now we
one question.
Yeah. Yeah, please.
Can I one question?
Sure.
That source G node B, how to decide it? That means it is already have a connection with that is called G source node.
So source G node B is the node which is serving the user at present. The source G node B is the BTS which is serving the user equipment as of now. And user equipment measures signal from the other G node B also and reporting to the source G node B. So source G node B has enough information about other signal strength and its own signal strength which is being received by UV. And then depending upon what threshold has been defined, it will trigger the handover.
Okay, sir. Thank you.
Okay. So now let's talk about SMF. So as the name suggests, this is session management function. And if I want to compare with 4G, so in 4G session management work was done by partially by MME, partially by serving gateway, and partially by PDN gateway. So basically function from these three entities has been taken over by SMF in 5G from 4G, just for a comparison purpose, so that those who know about LTE or 4G can correlate. Okay. So the first function which does is session management. So if you recall, I talked about creation of a PDU session, addition of more quality of service into PDU session, or maybe changing like terminating few of the PDU session once that is not required, and finally terminating PDU session itself. So these are all part of session management. So all the decisions are taken by SMF. All the decisions are taken by SMF. And as I'm talking about PDU session being a user plane functionality, so actual implementation is done in the user plane, but decisions is taken by session management function SMF. So now second function of SMS that since it has to manage quality of service, so it talks to unified data management and also talks to policy control function. So from unified data management, SMS gets what is the subscription of the user, what user has subscribed, right? And from policy control function, it takes various policy related rules. And then only it decides that what kind of QoS it has to create onto a PDU session. So it liaisons with PCF for policy and QoS enforcement. So they have got interface SMF to all other network function for this purpose. Now the question is, so I'll talk about UDM and PCF again, so don't worry. So what I wanted to explain here is every user or every subscriber will have some subscription that what kind of service he has subscribed for. So that data is there with unified data management, right? And the policy control related functions or policies are decided by PCF. So SMF has to consult UDM and PCF before it creates a PDU session and add quality of service. Because if suppose user has not subscribed some service and So SMF should not create that kind of PDU session and quality of service for that user. So based on subscription only services are provided. So for that matter, it has to consult UDM and PCF. Is that okay?
Yes, sir.
Yes, sir.
Great. Okay. Now the other function of SMF is providing the IP address. So allocation of IP address to user equipment is done by, please remember this because this will also be there in your quizzes. So IP address allocation is done by SMF. But do you think that SMF has to provide IP address in all cases? Yes or no? Do you think that for every UE, SMF has to provide an IP address? No answer?
Yes, sir, because it's a packet switch network.
No, it's not like it's a data network, not only packet switch. As I said earlier that it supports not only IP network, but also support some other kind of data network. So IP address allocation uh, will happen only in case it is a packet data kind of environment, IP. If it is unstructured data, for example, many of the IoT devices will not use the like packet IP kind of a data, but they will be using unstructured data. So in that case, there is no requirement of allocating an IP address. So IP address is not always, it is only when it is data itself is an IP. Data access is an IP. So it's a like it's not compulsory for each user equipment. Okay, now as we know that the data flows through UPF, user plane function, the diagram which I had shown. If you recall the diagram, the user plane data was flowing like from user equipment to Z node B to user plane function and then to the data network DN. This is the path of user data. This is the path of user data, not control, but user data. So which UPF will handle the particular call of the UE? So there may be multiple user plane function. There may be multiple instances of UPF. So which UPF will handle a particular call, data call or voice call or any type of call is decided by SMF. So SMF does selection of an UPF and then it controls. When we say control, in fact, that PDU session is created on the user plane. So actual implementation of PDU session is done by UPF on direction of SMF or on control of SMF. So selection and control of SMF is done by UPF is done by SMF. Now, very important aspects which SMF does is it does quality of service related, provides quality of service related information to 3 entities. So please remember that SMF, Madhukar, can you mute? There's some noise coming. May I request all of you to keep your mic muted? Only when you want to speak can open the mic. Thank you. Still noise coming. Okay, let me go back.
Professor Shivakumar. Professor Shivakumar, kindly mute your mic.
Or okay, let me mute everyone. Then go. Okay. Thank you. Okay, so let me open the PPT. The other important thing which I wanted to tell you is like the entire quality of service rules, etc. are provided by SMF to three entities. One is the user equipment. User equipment plays a very big role in QoS. Then the G node B, and the third is the UPF. So please remember, when SMF provides QoS related information to UE, it is called QoS rule. It is called QoS rule and provided to user equipment. Right? Before a PDU session is created, QoS rule is provided to user equipment. Then it provides quality of service to Z profile, we call it profile, QoS profile to Z node B. And to SMF it provides, we call it SDF template. SDF is service data flow template. This is nothing but filtering aspects. And using these rules, a particular service, suppose some data is coming from, those are IP packets coming from, say, YouTube, other IP packet coming from voice call, and so on. So with these rules, they will be able to segregate, filter, and apply a particular QFI, which I talked about, quality of service flow ID, and map different required resources at different places. So SMF role is to provide QoS role to user equipment, QoS profile to G node B, and service data flow template. We also call it a traffic template or PDR, packet data rule. So these are nothing but QoS related information being provided to user plane network functions, those network functions which are in user plane. So any question here before I proceed further?
Yes, sir.
Yeah.
Sir, accordingly, you said the resources should be allocated and deallocated.
Yeah.
Who will do that, sir?
So resource allocation, if you look at, there are many components. The first component is AR interface. That is between UV and Z node B. So UV and Z node B. So here resources are being handled by Z node B. And what are those resources? Those are RBs, resource blocks or subcarriers, and time.
Okay.
And when it is allocated on a particular TTI, either every millisecond or half millisecond or 1/4 millisecond, if you recall my earlier session.
Yeah.
So these resources are allocated for different QoS flow.
Okay.
Okay. Similarly, now this G node B is connects to UPF. From G node B to UPF. This is the other leg.
Okay.
So this is normally a backhaul, right? Maybe a fiber.
Yeah.
Right. Fiber or maybe a microwave. So here we call it GTP. Do you know the GTP? GPRS tunneling protocol. Some sort of tunnel gets created.
Yeah.
So resources here. Again from UPF to the data network, DN. This is also backhaul, fiber or Ethernet or any kind of backhaul. So here also the tunnel will be created called GTP, GPRS tunneling protocol. Okay. So on these, how much resources are being allocated is the question, right?
Okay. So between UE and G node B and G node B to UPF, and G node B takes care of allocation and deallocation. From UPF to DN?
So UPF to DN, UPF will take care.
Okay.
Yeah.
Okay, sir. Thank you, sir.
And of course, the control is with SMF also.
MF,
okay.
Yeah.
Okay, good.
Sir, if user quality requirements changes.
Pardon?
If user equipment's QoS requirement changes, then who will take care, sir?
So resources would accordingly be changed. Basically, every TTI resources gets updated. Either the same resource will continue or it will be dropped for that user or some modification will be happening. So every TTI decisions are taken based on the requirement.
Okay, sir.
Okay, now let's look at in this particular picture how a PDU session gets created. And so basically, if you look at the overall call flow, one of the item there is the session establishment request coming from UV to the AMF, right? Because UV have only access to AMF in the core network. Now AMF has to discover that particular request will be handled by which SMF. There will be multiple instances of session management function. So there is a network function called NRF, network repository function, which has address of all the network function, including SMF. And also it has profile of that SMF, that what kind of services it offers. So the AMF will discover from NRF the list of all the SMF with their profile. So NRF will provide to AMF list of all the SMF onto the network and with their profile. So now AMF will select a particular SMF and ask that SMF to create a PDU session. And then SMF takes over and does all those activities internally with UPF, etc. and creates a PDU session. And once that is done, it informs to AMF that PDU session has been created. So this is a sort of flow or creation of a PDU session in a very, very brief and short. So detailings are also available in the standards, which are actually implemented, but this is just to understand. Okay, so let's look at different interfaces of SMF. So as you know, there are two interfaces which we can see. So I'm referring here to the reference point architecture. Service-based architecture, these all are replaced with the API environment. And then we have N7 interface, N4 interface. So there are four interfaces which SMS is handling. So basically, if you look at AMF and SMF interface, which is N11, right? So in this case, as we discussed that whenever there is a requirement of creation of a PDU session or addition or deletion of a PDU session, modification of a PDU session, AMF is giving direction or requesting SMF to do that on N11 interface. And then it has got interface with N4 interface with UPF. So basically, whenever there is a request to create PDU session, the SMF has to send certain messaging to UPF for creation of PDU session. So it has got a N4 interface with UPF. And then as I discussed that it has to talk to PCF to get policy related information. So you have a N7 interface. And finally with UDM where subscriber data is present. So that is the N10 interface from where it gets the subscriber profile. So these are interfaces. Similarly, I had not discussed about AMF interfaces. So AMF interfaces are like N1 interface from the user equipment. Of course, practically it will go through G node B, but it is transparent. G node B to AMF is called N2 interface. And AMF also connects with, say, PCAF for policy control function and also to the UDM for subscriber profile. Okay. Now let us move towards UPF. What are different function of user plane function? UPF where PDU session flows. So as you can see in the picture, PDU session is from UV to G node B to UPF and then to the data network. So where user data flows. So UPF is in the user plane as the name suggests. So the first is the UPF plays a role or plays as an anchor point during the NG RAN mobility. So what I'm trying to say here that suppose there are multiple number of G node Bs into the network and they are connected to UPF in that region. And then this UPF gets connected to any data network or multiple data network. So when a user move from this to this or this to this, the anchor point is UPF because UPF is not changing. I have moved from one G node B to other G node B and vice versa, but my UPF remains same, only path switching is happening. So that's why we are calling that UPF act as anchor point during NG RAN mobility from one G node B to other G node B mobility. Now UPF, as I said, is in the user plane. So based on direction from SMF, actual implementation of quality of service has to be done by UPF onto the interfaces between UPF and data network. Okay. On air interface, we know that G node B provides resources, but on these parts UPF handles. So it ensures quality of service. Now to ensure quality of service, suppose there is a downlink data. Let me try to explain. Suppose there are multiple downlink data coming. How it comes? Like after UPF, you have DN, data network, multiple data network. It may be internet, it may be IMS for voice call, it may be any other IoT server and all. So basically there will be multiple data coming in the downlink direction. I'm talking about downlink just to make you understand. So it will go to the UPF. And UPF, how it will know that the data is coming from internet or IMS or IoT server, or for that matter, any service. So it knows how to filter it, right? Maybe based on IP address, maybe based on port number, it will filter it and apply a particular QFI onto the downlink direction. For uplink, user equipment takes that role. In downlink, it is the UPF which takes the role. So it is called SDF filtering. SDF is service data flow. YouTube is a service, Netflix is a service, gaming is a service. So every service data flow, UPF will be able to filter based on the rule it has received from the SMF. Right, template it has from the SMF, and then you can apply a particular QFI. And of course, packet routing and forwarding is one of the major function of UPF because all the data, user data has to flow through UPF. So it also acts as like a connectivity towards the outer network because it is connecting to DN, IMS, all kind of data network. So it's a interface towards outside 5G network. So these data network are not part of 5G network. They are outside 5G network. These are services. So it acts as a gateway or interface. It is just like PDN gateway of the 4G as far as gateway function is concerned. Any question here or shall I proceed?
You can proceed,
Yes,
sir.
sir.
Thank you.
Thank you. So what are the interfaces of UPF? The first interface is the N3 interface. So N3 interface is towards UPF, right? What is the next interface? That is the, I want to tell about N9 interface, which is not mentioned here. So what is N9 interface? Any of you can tell me? If there are multiple UPF, suppose UPF 1, UPF 2, So Z node B to UPF, and then UPF2, and then it goes to data network. So this kind of things are also possible. So the here interface between two UPF is called N9 interface. So N9 interface is nothing but interface between two UPF. Okay. And then you have N6 interface of UPF towards the data network. When you have to connect to data network, your interface is called, sorry. Just a moment, I think. Why this is coming. Okay. Okay. So we have talked about N6 interface, and finally N4 interface is towards the SMF. It receives direction from SMF from the SMF on the N4 interface. I request all of you to just try and remember these interfaces. There will be certain questions onto the quizzes. Yeah.
Sir, when there is the need of more UPFs?
Okay. So you are saying, suppose, so basically in the network, there'll be a UPF which connects to, say, suppose this is an UPF, it connects to internet data network. There may be some other UPF which connects to AR/VR gaming, AR/VR. There can be a SMF UPF which connects to the gaming service. So there will be a UPF which is in the chain coming from G node B, and it will do the branching of the different services to the respective UPF. It is not necessary that I connect all services to a single UPF. I can use multiple UPF for different connecting to different outside network, and there can be an intermediate UPF to route the call of the user to different UPF in the network. So in this case, I have a N9 interface here. That is one of the requirement. Is it clear to you now?
Yes, sir. And then it means simultaneously different data can be fetched, sir, like AR or
Correct.
internet.
Yes. There can be other use also. For example, in case of a roaming, in that case also some data flows between UPF of home network and UPF of visited network. So there also they get connected on N9 interface. It's a very good question you asked, and that's why I could tell you something more. So more of the question, more of the information you get. So it's very good to have an interactive session so that more and more informations are shared. Okay, now let me talk about UDM. UDM stands for Unified Data Management. So basically UDM is what? UDM contains data of the user profile. Okay. So when you provision a user into the network, that profile gets registered in the unified data management. It also contains one more profile, like in a network. Yeah, please go ahead.
Sir, this user data, it's a multimedia data, right?
No,
Only
not data, profile. Like
user.
when you take a subscription, so suppose you have subscribed to a service which gives you only 30 Mbps. So that information. Suppose you have subscribed AR/VR service, so that information. So your profile data, not the multimedia data or anything. Okay.
So
Profile
about the
information.
metadata kind of user, right?
Correct.
Thank you, sir.
And similar, and now in the network, there will be many data network connected, right? That may be IMS, that may be internet, that may be a gaming service and all. So every data network also has certain profile, what service it offers, which customer has subscribed. So data network profile is also stored in UDM. So this we call it data network profile. So this is also in UDM. So it contains registry of subscriber information, and data network profile. What is the next one? Next one is access authorization. So UDM plays a role in access authorization because only UDM knows that which service has been subscribed by a user. So whenever user is trying to access some service, authorization has to be made. Although authorization will be made by AMF, but that data is with UDM. So UDM provide that subscription data to AMF, SMF, and other network function as and when required. So it is involved in access authorization in that sense. Third is that for the first time, when UV connects to the 5G network, the process is called registration. The registration process. So registration process also, since it has got subscriber profile data and all, and also it contains certain more aspects. So all the other network function consult UDM for those information. So so we call it that UDM is also involved in registration process. Second is that UDM also is involved in the mobility management. How it is involved? That which AMF is handling a call. Which AMF is handling a particular call is always available with UDM, right? So at particular time, say AMF1 would be handling a particular time, maybe AMF2 is handling the call. So that means it knows that which AMF to query to get information about that user. And this becomes useful in case of a roaming environment, right? So if user is like somewhere, so the maybe a visited network or home network query to each other to get the information. So UDM will always have where UV last serve AMF or last serving AMF information will be there in the UDM. So for the purpose, and it is used for the purpose of mobility, right? So it is UDM which has got that information through AMF.
Sir,
And finally,
sir, how many AMF instances, sir, then? It is based on
how
the
many?
number of UEs or it is based on the services, sir?
So it is both. So depends upon how much users you have, how much traffic you are handling, what are all other services you have. For example, in 5G, there is a concept of network slicing we had discussed a little bit earlier. So it is possible that some instances of AMF are only part of one slice. Other instances of AMF or SMF or UDM are part of other slice. So within slice also these network functions are divided, and there are certain common network function which may belong to multiple network slices.
Okay, sir. Sir,
Right?
there is nothing like one AMF for one UE.
No. So it's all dynamic. Generally, geography, suppose it is also geography was divided. In a particular geography, you may have one or multiple AMF, and they know that like standard says that you can configure like from IMSI X to IMSI Y in your region, this particular AMF will be handling. And there is also concept of switch over of AMF. Suppose UV connects to one AMF, right? And then a request for a service which is not handled by that AMF. So there will be a kind of from one AMF to other AMF, the switchover will also happen depending upon the requirement. So those processes are also there part of 5G.
Okay, sir.
Sir, maximum one AMF can handle how many UEs?
So depends upon how big you are making, how many resources. So the 5G equipment, as you understand, is like virtualized network function. You deploy that on a hypervised or virtualized infrastructure.
Yes, sir.
And so for that matter, even in your laptop, a simple laptop, you can deploy the entire 5G core. There are many open source core available. So there,
Okay.
since you have a less compute and less memory, etc., so you may not be able to handle large number of UE in a particular AMF. But suppose instead of that, you are having a server which has got very huge compute and memory, so you can handle more. So depending upon how much resource I allocate to a AMF or SMF or UDM, that will decide how many user that can handle.
Okay, sir.
So
Thank
there
you,
is
sir.
as such standard do not bar that how many one AMF. So generally what will happen, I'll tell you, many of you might be knowing about Kubernetes. How many of you know Kubernetes?
Yes, sir. We know
Okay,
little.
Yes, sir.
okay. So
Containerization.
basically two types of virtualized environment generally we use. One is the VM, virtual machine, all of you must be aware, and other is the containerized environment, right?
Oh,
So,
yes, sir.
so generally all the operators would be using containerized environment for deployment of 5G. So in a containerized environment, you manage that using Kubernetes or a similar kind of a management and orchestration. So there you have a provision that if traffic increases, then you can increase the resources dynamically to a particular AMF or SMF. Then if traffic increases, you can configure that, okay, next instance of AMF or SMS gets created automatically.
Yes,
Or
sir.
suppose one AMF fails, then automatic switch over to other AMF. Those are all possibility with a containerized environment once you create. So 5G is very flexible in that sense.
Yes, yes, sir. Thank
Okay.
you, sir.
Okay. So what are the interfaces of UDM? You can see that there is a NET interface with AMF just to provide subscription information and also during the authentication authorization. Then you have N10 interface with SMF. Right. Now the part one of 5G core. The next is PCF, policy control function. So what are the role? So basically, as the name suggests, policy control. So it also takes dynamic decision based on present network condition. For example, suppose a user is in an area where network resources are poor. And suppose this user was having a service which was using a very high data speed. And then PCF knows all those information that now it is an area which is poor and we cannot serve. So PCF may take a dynamic decision to throttle the speed of that user. So that is kind of a dynamic decision it can take. This is the example which I tried explaining. The other is that correct resource allocation to a particular user equipment. That decision also comes from the PCF. And in addition, like as you know that as I explained that SMF does QoS related rules, profiles, and template, but it does based on packet data rule provided by PCF. So basically basic information is provided by PCF to SMF, and based on that SMF creates those rules for UE, profile for Z node B, and SDF template for UPF. So this is the another function of PCF. Okay, so what are the interfaces of PCF? It is N7 towards SMF, and there is a N15 interface towards AMF, And you also have connectivity towards the data network. It also talks to the data network. In particular, we call it application function for quality of service. So with this, the part 1 is over. We can discuss, and also we can break for a few minutes for all of you to. I can take few questions before we break. If any of you have any questions, you can just ask me.
Sir, this core network, where exactly
Sir,
it can
am I audible,
apply?
sir?
Yes, yes.
Sir, with respect to 4G, we have a MME, S gateway and P gateway. So
Yeah.
these functions where they have compressed and kept in the 5G elements, sir. And what are all other patches? I think as you mentioned somewhere, the control plane and the data plane are merged together in 5G somewhere. But in 4G, we have two different plane. So can you elaborate more on these two aspects, sir?
Okay, so actually what you said is reverse. Let me try and explain this. Just a moment. I'll take a blank page and then try to explain that.
Okay, sir.
What I recall, your first question was
Sir, in LTE, that is 4G, we have a MME, S gateway, and P gateway. These three things comprises of so-called
okay.
EPC.
Okay,
Whereas in
so
5G, we have 5GC. So these three functionalities, which element in 5G takes
okay,
care of it?
okay. Just here. MME. Can you see the screen?
Yes, sir.
Uh,
Able to see, sir.
Yes, sir.
I was hearing a lot of noise. So
You're able to
Madhukar,
see.
can you mute some of persons so that?
Yes, sir, meeting.
Okay. You can mute all. Yeah. Okay. Thank you. I think the question, the one who asked the question may also mute it, but you can open and ask further. Okay. So
Yes,
the MME, the function of MME in 5G is now being handled by access and mobility function plus session management function. In 4G, AMF does mobility management and part of session management. Okay. And now
do we have still something called SIP, session initiation protocol, like SIP in 3G? So still is there?
no, I mean, there's nothing, no element like that. Although functionality would be there inside, but no such element. Okay. And in 4G, you had serving gateway, SGW, and you had PGW, right?
Yes,
So
sir.
these were handling your, one is the user plane data, plus they were also doing session management, part of session management, not fully, because MME was also involved. So if I just say that session management was done in 4G by MME, SGW, and PGW. So that means SGW, PGW, not only user plane, but also control plane. So if I want the equivalent of SMF, right? So basically SMF function has come from MME, some part from MME, some part from SGW, and some part from PGW. So this is the equivalence. because MMF was doing session management and also mobility management, and these two user plane plus control plane related to session management. Okay. Now coming to UPF, there is only one network function is 5G, which is called UPF. So this has come from SGW plus PGW, part of it, because SGW PGW also does session management. So the user plane part of SGW and PGW is now into UPF. So that this part is clear to you, or any supplementary question here?
Yes, sir. That is clear.
Now your next question, let me try and answer. Your next question was about the user plane. So in 4G, what was the user plane? From user equipment to E node B to serving gateway to PDN gateway and to a particular PDN. So this was your user plane. Is this okay?
Yes, sir.
But problem was these two.
How about control plane, sir? Control plane.
Let me first explain this.
Yes.
So in 4G, SGW and PGW is handling user plane data, but they also handle control plane data, because session management I talked about, right? Session management is the control function. And that's why in case of a 4G, you have to take your call to the core network in a centralized core network, even if the call is for the next person. So there was no separation of UP user plane and control plane in 4G. You got my point? In 4G, we didn't had a clear user plane and control plane separation. But in 5G, it is distinct. Like in 5G, your user plane is from user equipment to Z node B to UPF and then to a data network, any data network. So here UPF do not have any control function. It is just user plane. So in 5G, UP, that is user plane, and CP, that is control plane, are completely segregated. Understood? Do you have any supplementary question?
I think some books or something, some places, they do say these two planes are separately. That is the way I got this query, sir.
No. So basically, I'll tell you what you might have read. If you
Yes,
go to release 14 of LT, just before 5G release 15, because everyone wanted to migrate to 5G, their 4G network. So what 3GPP had done, that the SGW box, which you have in 4G, they divided this into two parts. SGW, that is user plane part, and SGW CP part. Similarly, the PDN gateway, they divided into two. One will handle user plane, another will handle control plane, right? And this was called CUP, CUPS. This was called CUPS. C is control plane, U is user plane, UP is user plane, and S is separation. Control plane and user plane separation architecture of LT came in release 14 just before 5G, so that the 5G and 4G architecture looks similar. Okay, so this came in release 14. Very few network in the world were at release 14, but once they are migrating towards release 15 of 5G, they have also migrated to their release 14. And that's why with this, we can say that CP and UP in 4G are separated, not before release 14.
Understood, sir. Yeah, because I might have referred to this release. Yeah.
Yeah. Okay.
Thank you, sir.
Okay. So I think any more question? Yeah, please.
Sir, can I ask one layman question?
Yeah. So I'm trying to teach in a layman manner only everything. So I'm not going into very
So
mathematical.
the one profile creation, you profile point, I asked the question. So
Yeah.
normally when we are selecting the packages, sometimes the mobile phones is giving the cost. This is the your package you can select. So when we choose that package, can the system will create the user profile, or we need to fill all the details?
Yeah.
Question
It's
is
their internal thing, no? So only thing that when you subscribe to a service, suppose I go to Jio and choose a particular plan. So corresponding to that plan, all they know what configuration they have to do in different network element, UDM, etc. So they fire the command internally. So if some of you have worked in a telco network, there is a order management system wherein based on, suppose somebody comes to your house, you buy a new SIM, right? So initially it will not work, right? So once they put it into your system, automatically their order management system comes into play and they configure wherever required. So all those places where data changes are required in the network, not only in the network, but in the billing system, they will have an intelligent network there. They'll have so many network function and other accessory where there may be requirement of creation of your profile or configuration of something. So those are done with the help of a order management system, which all operators would be having generally.
Because sometimes they will recommend this is suitable for your work automatically, observing the behavior of the user, how they are using.
So those are on top of the network. They have those are called OSS BSS, Operation Support System,
when we
and
select
Business
it,
Support
the
System.
profile will be created automatically, right, sir?
Yeah.
Okay, that's awesome.
All
Thank you
those
very much.
suggestion which comes from their different system which they have.
This is the AI concept where the behavioral observation and other thing kind of thing. Thank you very much, sir. Because always we used to get why they are giving these packages and other thing. So today's session, it is cleared. Thank you very much, sir.
Okay, so let's shall we proceed or you want 5 minutes?
Yes, sir, you can proceed. Maybe if everybody is ready, you can proceed.
Okay, I'm considering everybody to be ready. Okay, no problem. Okay, so now part 1 was over. So let's continue with part 2. So in part 2, I'll try to cover, I'll try to explain about service-based architecture. Till now, I was talking about reference point architecture. Functionalities remain same, only how they interact changes. And there are certain new network function. One is called network repository function, application function, authentication server function, network exposure function, network slice selection function. In part 2, this we will be trying to explain. So if you look at now service-based architecture, just see this picture. I don't have so many.
Share the slides, sir.
Okay,
Unable to
sorry.
see.
Okay, I think I didn't share. Okay, please wait. Thank you for reminding me. Is it visible now?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. Presentation mode. Okay.
Okay. So if you compare with the earlier architecture diagram which I shown, you find certain difference. That difference is here on the top side. Difference is here on the top side. You see that I don't have those reference point interfaces. Now I have these interfaces. These are called service-based interfaces. It's nothing but HTTPS kind of a interfaces, or we call it application programming interface, or sometimes you also call microservice. So now interfaces has become flat. So any network function can talk to other network function on API. And that's why we call it service-based architecture, because every network function provides certain service and other network functions can consume that service or vice versa, right? So one network function can be a service producer, can also be a service consumer. But you still see some of the interfaces as reference point architecture. Those are towards the user plane. Just see, if you recall, in 5G, our user plane is this UV, radio access network, user plane function, and data network. This is part of the user plane. When user plane is getting connected to the top side, which is control plane, we still have, say, N4 interface from UPF to SMF, N2 interface from RAN to MF, and N1 interface from UV to MF. So this reference point interfaces remains here, but rest all control plane network functions are now on a service-based interface. So what benefit I get, or what I'm talking about, is a service-based architecture. Now I have completely segregated user plane and control plane. You can see top part control plane and below part as user plane. Now, since user plane is segregated, unlike 4G network where PDN gateway and serving gateway was also doing certain control function like session management. So it was not possible for 4G to locate those network function near to the user. But in 5G, now I can place this UPF and connect to a data network locally there. For example, if Jio has rolled out 5G network across the country and their core is in Mumbai, they can still locate their UPF in, say, Patna, Hyderabad, other cities, and connect to the local service. For example, if suppose in Tamil Nadu, there is some local language service requirement. So that can be hosted near to the user, the UPF and data network in a small data center there, right? So now there will be a lot of data center coming in tier 2, tier 3 city where user plane function along with some service can be hosted. So that's the beauty of separation of user plane and control plane into different part. And as I discussed that control network functions talks to each other on API. Now outside network, I was explaining that operators will have operation support system. They may have business support system. They may have third-party applications. So these need to be connected to 5G network for which there is a special arrangement called NEF, Network Exposure Function. So all these OSS, BSS, and other third-party services can connect to 5G network through NEF using the API interface, Application Programming Interface, HTTPS or REST API if you have heard about, RESTful API. The other thing which has happened, any
Sir, I
question?
have one question.
Yeah.
Sir, actually, when we established this 5G lab at our side from your equipment, whatever you have provided, how exactly the concept of control plane and user plane happens there? Because the user plane near to the RAN we are telling, I mean, user equipment, and control plane can be kept away. So that
Right.
visualization can we do in our setup, sir?
So what you can do that, suppose you have two different boxes. That means I'm talking about server. Suppose you have a two server. So in one server, you virtualize and put all these control function. Right? And another server, you deploy UPF separately, right? And also some application in that particular server. And now these two boxes can be apart. So practically you can keep in same room because you have a lab environment. But if you take to other building, other places and connect these two, if you have some backhaul connectivity, maybe fiber or Ethernet connection between the two places, you can see that user plane you are able to segregate from the control plane, and also connecting to internet, IMS you can do locally from the the other place where you have a UPF. So that kind of thing you can see. And this was not possible in 4G because 4G was part of the control plane itself. And that's why they had a completely centralized architecture. Only radio used to be there in the field, and that the traffic used to go up to the core. In 5G, the traffic can terminate it to data network locally also. So there will be some services which will be hosted centrally. There will be some services which can be hosted locally in 5G.
Sir,
Did I answer
then
your question?
yes, sir. Then, sir, as of now, in our setup, both are together.
So basically, initially they may configure all thing into one box, but they are giving you another box also, another server also for edge. So you can do experiment implementing UPF in the other server and see whether it's working or not. So that kind of experiment you'll be able to perform.
Yes, sir. Thank you, sir.
Rather, you should insist with the vendor that they should like all those permutation combination, they should show you as part of their installation commissioning. And that's why this particular training will come very handy. You'll be able to ask so many questions, right?
Yes, sir. Thank you, sir. Yes.
Otherwise, it is difficult to understand what they're trying to do. So you can ask so many questions after this training.
Yeah.
Okay. The other thing which has happened is now these network functions are VNF, virtualized network function. That means I can deploy on a cloud or on a bare metal on a hypervised environment, right? So that's the benefit I'm getting. So you can create a cloud, local cloud, and deploy these network. Okay. Now the network function which I want to talk is the NRF. You see this NRF. So if you recall, I have already spoken about AMF, SMF, PCF, UPF, RAN. We had one day talked, right? So now remaining is UDM also over NSSF, NEF, NRF, AUSF in this picture. So we'll try to cover this also. So NRF, first NRF, this one. I'm talking about the NRF part. So what is the function of NRF? The full form, as you can see here, is network repository function. So what is this? So basically, whenever a new network function, any new network function is created, it has to register into NRF. Suppose I create a new AMF. Okay. So the first thing this new AMF will do is will connect to NRF and register itself. That means register means the IP address of this AMF or its URL, we call it FQDN, fully qualified domain name of this AMF will be registered into NRF. And it will also have profile of this AMF. So all network function, be it AMF, SMF, UDM, all network function are supposed to register when they are created. So that is called service registration. And then these are maintained by NRF. I mean, it will always be up to date because not only service registration, but also the update, right? So for example, this AMF undergoes certain changes. So that update would come to NRF. NRF has to be updated. So it will always have the NF profiles, all the network function profile NRF will always have. And then there may be multiple instances of AMF. Suppose there are 10 AMF. So each instance has to register. Each instance of AMF has to register. So maintain NF instances also. And then the other function is the service discovery. What is service discovery? Is like if other network function want to talk to some network function, for example, suppose AMF want to talk to SMF. So the first AMF goes to NRF and discover the SMS, that is list of SMF, and then it selects which SMF it has to interact with. So this is called service discovery. So this is the function of NRF. So if you recall, this is not there in reference point architecture, which I explained, because there was no requirement. Each network function or pair of network function had a dedicated interface. And since here I have a common interface in an IT system like environment, so I need this NRF to register and discover a network function. So this picture I had explained earlier, that how a session is established and how AMF discover SMF through NRF. So I'll not repeat, but you can recall or look at the recordings later on. Okay, the next network function I want to talk about is NEF, this one. Little bit I explained earlier. As the name suggests, it is a network exposure function. It exposes a REST API towards outside world for third-party applications. That can be OSS, BSS, or for example, the IoT. Suppose network has to support IoT, so IoT server will be connecting to 5G network through NEF. Suppose there is a V2X, vehicle to anything, autonomous vehicle, there is a server. So that will connect to network through NEF, right? So the entry into 5G network for third-party applications or other vertical like of use cases will connect through the NEF. So that means NEF has got exposure capability. It exposes the capability of 5G network to outside world. And suppose in a 5G network, lot of data gets created. For example, if it has got IoT sensors, a lot of data will come from the sensors that is required to be sent to IoT server. So events has to be exposed to outside world. So that is the thing which will be done through the NEF. And this is also like outside 3GPP network. If something is to be provisioned, it is done through the NEF. So NEF is a secure element to connect to outside world of the 5G network. And of course, there'll be a translation work happening because it has to talk to many kind of things. So inside it is one kind of communication, outside it is a different. So all those internal, external information translation will happen at NEF level. Okay, the next network function which I want to talk about is the network slice selection function. So we had discussed about network slicing earlier. And network slicing is nothing but dividing your network into many virtual network for different use cases. So which slice is to be selected? So as the name suggests, it is network slice selection function. So it normally assists AMF in selection of a particular network slice. If there are suppose 5 network slices in the network and user is to be connected to which network slice, that information is gathered by AMF using the services of NSSF, that is network slice selection function. And it also has information that a particular UV, whether it is allowed to a particular slice or not, there can be multiple slice. UV may only be allowed in slice 1, may not be in 2 or 3. So this information is also there with NSSF. So it determines which slice is allowed. So here we call it NSSAI, Network Slice Selection Assistance Information. Network Slice Selection Assistance Information is called NSSAI. That is nothing but which slice is allowed to a particular UA. And then finally, in many cases, a particular network slice will be handled by an internal AMF of that slice. So the outside AMF, right, has to connect to a particular AMF of that slice. So that means NSSF will assist AMF in allocation of required AMF supporting that slice. So these are brief or broad function of NSSF. So this is another diagram related to the network slice, wherein so what we call it, suppose there is a slice for handling enhanced mobile broadband, there may be a slice for handling URLC application, there may be a slice for handling massive IoT, there may be a slice for handling V2X. So these will be called network slice instance 1, instance 2, 3 and 4, and it will have a value SST value, we call it 1, 2, 3, 4, right? And then for example, a smartphone will be handled in this slice, AR, VR or other services will be handled here, IoT services or autonomous car will be handled in this slice. So if you look at the end-to-end slice, so you have access, right? So you have access, that means maybe G node B. You have access, then you have a transport, that is the backhaul, and then you have a core network, and then the applications, those servers of EMBB, URLLC and all. So at all level, the slices, so end-to-end slices has to be created. So here we call it network slice subnet instance in the access. Then transport connectivity, you will be having different tunnels, IPsec tunnels. In the core network also, you will have slicing. And then of course, it will connect to different services. So this is end-to-end slicing concept, which can be done in 5G. Just for your information, that the lab which is being supplied to you can support up to 3 slices. If you look at the tender document, it will support
core network, sir. The slices it will give, sir. First,
you can configure
block.
up to 3 slices, and you can change those slices over a period of time. That means I mean capability to create 3 slices you have. Otherwise, in a standard, you can create any number of slices. If you look at the standard, one can create, but your lab is coming with a capability of creating 3 slices.
So this is the mainly experimental purpose. We can take this slide information.
Yes, exactly. Yes, yeah. The next network function I want to talk about is AF, application function. So basically, there'll be 2 kind of application. One application which the operator itself is hosting. So they will make part of the core network, inside the core network on the same connectivity bus. But if it is a third-party application, then it has to connect through NEF. This application function will be connected through NEF. Application function means, suppose there is a third-party service for V2X, third-party service for AR/VR. So those are application functions. Those are connecting to NEF through NEF. In fact, the architecture is like their data part will connect to UPF, and their control part through NEF will connect to the 5G core network. So provide services, support application influence on traffic routing. This is very beautiful statement. So means what? That as 5G, as I said, that you have UE in the user plane, then you have a G node B.
Sir, once again, could you repeat that, sir? Which part is connected through?
Okay.
Application function, third-party application function.
So application function will have 2 components. One is where services will be provided, that is the user plane data, and other is certain control aspects, right?
So that will be connected through NEF.
Through NEF, and other will connect to the UPF as part of data network. And the statement here is like it will have influence on traffic routing. So what happens is that AF may request the 5G core through PCF that it provides the service at the edge itself, and it is connected to UPF. So some part of the traffic is terminated near to the UPF in the application function part there. And some of the traffic may go to a central location, right? So traffic influence, application influence of traffic routing, because this AF is asking PCF to do so. So that kind of environment is possible in 5G. And of course, through NEF, third-party applications are accessing the 5G network. And it interacts with PCF for policy control. For example, the application function tells PCF that what is the quality of service required for a particular service it provides. So that way it has an interaction with the PCF also. And now we'll talk about AUSF, authentication server functions. It's very simple that it acts as an authentication server, and all the security procedure which happens during authentication authorization, AUSF is responsible. It is a similar function we do in other 4G, 3G. Okay, so we talked about many network function. We'll just list out. So I talked about AUSF just now. We have discussed access and mobility function. We have talked about data network. There is a network function called UDSF, unstructured data storage function. So basically, different data which are not structured may be related to IoT. There will be a network function called UDSF. Then I talked about NEF, NRF. There is one new network function which I have not talked about. I'll talk about this when I'll teach you network slice. Is network slice specific authentication and authorization. That means within the network slice also I can do authentication and authorization. So that is NSSS, NSSAF. This NSSF I talked about, PCF I talked about, SMF I talked about, UDM I talked about. There is also something called Unified Data Repository. I'll talk about it tomorrow. So, I mean, let me mark as a cross so that you know that this is not covered. And then UCMF, UV Radio Capability Management Function. So this I will talk in detail when I take session on different IDs and addressing of 5G. Application function we talked about. User equipment we talked about. Radio access network we gone into detail. This network function is equipment identity register. Basically the EMI if you have heard, the registry of EMI is available in the EIR. Even the blocking and all we do through this. So this I have not covered. And then we have network data analytics function. This is new thing which came in release 16. So this is where AI ML processing can happen, because this will have huge data from the network. And of course, there will be a charging function because operator has to charge for the services. So broadly, I have discussed. I'm not going detail into other network function which I didn't discuss. You can always look at this if required in the standard document, which you can find out. And then we have more network function in 5G. One is to support non-3GPP, that we call it N3IWF. We also have trusted non-3GPP function TNGF. Then we have a wireless access gateway function WAGF. Then we have a trusted wireless networking function TWIF. And for security, we have service communication proxy and security protection edge proxy. This we will be talking about in our session tomorrow. So I would like to finish here. We are on very right time that we have covered two parts, and rest of the two parts will be covering tomorrow. So again, I'll open for question or discussion, and I'll be sharing the quizzes also today. So maybe I request everyone to open your mic video and have some interaction if you need, or otherwise also. Thank you. Any question or anything?
Sir, are there any simulators, sir, so that we can make our students to work on this as part of 5G lab in the class and the department?
So if you all agree, I can call one of the vendor who has created a complete 5G simulation for the education purpose.
Okay,
And of
sir.
course, those are commercial products. So, but he'll be able to explain about all the capability of that product. It's a Kolkata-based company, I know. So if you all of you agree, then I can request him to take 1 hour or 2 hour session for all of you, so that you are aware of.
Sure.
It will be great, sir.
Yeah.
Because
That
we
idea is very good.
want to establish the lab, it will be very useful. We can directly connect to them.
So I'll talk to him and I'll take his team time that on which date he can carry that, and let you know. I'll inform you that.
Thank you, sir.
Okay. Madhukar, please note it down and remind me so that I speak to him.
Can I have one more question?
Yes.
Yeah, please go ahead.
Whatever the lab facility, that equipment and providing, if you want to change some of the functionalities or improve, in which code they have developed it? Is it
So
MATLAB or
I think there are many vendors for different region, and there are many OEMs equipment which are being integrated. So offhand, I may not be able to tell you that which language they have used or what. But whenever I mean those are supplied, it is expected that you should be able to do the experimentation. You should be able to do connect. Suppose you yourself create a new network function, maybe AMF, and want to test that. So you should be able to do that. Those you have to insist with the vendor that suppose all the aspects of AMF are already those are defined in 3GPP standard. If you have a good coder in your organizations and you want to use his services to code AMF or SMS, and you can do that and you can test. Also, there are open source network function available which you can download freely and make changes as per your research, your thing, and try to connect to the network. Similarly, you can create some use cases, connect to the networks. Those should be the possibility. You have to actually really be behind your vendor once he supplies, because generally he will try to go away once install and all, but you have to always keep in touch, because we also have a contract for, I think, 3 years operation and maintenance. As part of that, he should support you.
okay, sir?
Sir,
Thank you.
please ask them also to do that same, sir, because they are busy with other colleges. So
I will actually, what I'll do, implementing agency for these labs are TCIL. So maybe I can ask TCIL person one day to give a brief that those equipment will be supplied to different colleges on what date, and what is the timeline currently they are able to see through. So that is also a possibility. So that will give you the more detail about dispatches and all. You can ask a certain more question if you have.
okay, sir. Sir, you said about there are so many open sources. So
Yeah.
you please provide the links for that also, sir. We'll try working on that.
5gc.org is one where you can just Google it, open source 5G, lot of website will come.
Okay.
So but I'll tell you one or two good one, like 5gc.org is one, and there are many others. So and if you want a session wherein I can one of my young officer can actually demonstrate you live installation of a open source 5G core in a laptop. So if you guys are interested,
great,
I can.
Sir.
Yes,
so
sir.
we can arrange that also. It will be great. So, but that would require about 3 to 4 hours of your time. And he will tell you that what are the things you should keep ready, so that you also do it parallelly along with him.
Okay, yes, sir.
So that is also a possibility. Madhukar, please note it down. We'll try to fit in somewhere this also, because that I think will give them a better idea. Even without the current 5G lab, you can create your own 5G lab on the hardware which you may already be having.
That will be great, sir.
Because it is difficult, sir. We cannot allow students to go to that lab and access all those things. They can only work with their use cases.
You can actually ask all the students to deploy 5G core in their laptop,
Yeah.
and that can be a project for them.
Yes, sir.
And then I mean, we will also teach you that how to connect to the current Wi-Fi and make a call, like a WhatsApp call from one device to other device,
Okay, sir.
using your own laptop based 5G core.
Sure, sir.
That's good.
Thank you so much, sir.
Thank you.
Okay.
Thank you, sir. It's very nice.
Thank you, sir. One question.
Yeah.
Normally, this mobile, the communication, 5G communication or 4G communication, any communication, we feel that it is a secure and it's only whomever communicated, those people only have the data. But whenever the some kind of, this is out of this thing, but still in security part, I just want to know, sometimes if the people, police or these people will recollect entire the communication and data kind of thing. So what
Okay.
policy make them to access this data?
Very
Is there
right.
any?
So yeah, very right. So every country have got its own law. For example, in India, if you read the Telecom Act, there is a provision that in case there is some illegal thing happening, or in the interest of nation, in the security of the nation, there is a process defined. If those law enforcement agencies like CBI, etc., want to monitor individual call, so there is some approval process, like Home Secretary of the Government of India has to approve, or in a state some authority has to approve, and that approval goes to say operator, and based on that approval, operators enable monitoring or interception of that particular call. And also certain metadata like your call data record, etc., or your location can be provided to the police or such authorities. But of course, after they have obtained approval of a uh, very senior level officers of the state or central government, either Home Ministry does it in the center or equivalent officer in the state government. So it's not that everyone can monitor anyone. It's a well-drawn process as per the law which happens.
So failing of any of these process, we can take is a tapping or something, right? Sir, illegal kind of thing.
So illegal tapping generally, I mean, so you might have heard that somebody can intrude into system, and so although we are using, say, some sort of encryption, ciphering in every aspects, but still there may be certain hacker who will be able to penetrate. So IT world, nothing is 100% safe. Every time we deploy a new technology, for example, if you recall internet banking, earlier we used to, you might have seen that it is 128-bit encryption,
Yes, sir.
right? SSL, and nowadays it is 256-bit encryption they are using, because 128 people were able to kind of break it.
Crack
So
the
they
boundary.
went to 256. Similarly, in Aadhaar, you might have heard about UIDI or Aadhaar. When you do enrollment, your data packet gets encrypted with 2048-bit encryption, a very high level of encryption they use. So depending upon requirement, use different ciphering algos, right? And now we
Yes,
have
sir.
started talking about quantum safe algorithms to
Yes, sir.
become future proof. So basically, as the threat increases, I mean, so you also increase your level of encryption or level of
Because nation
security.
also DST project is connecting quantum communication, and where actually it is coming quantum computing and 5G, 6G technology integrated projects kind of thing. Yeah.
So
Thank you, sir.
quantum will become part of, say, 6G going
Right.
forward, or maybe as on today, at least the ciphering part we can use quantum. There is a lot of innovation which has happened in India also. If you, I don't know whether you are aware, one of our autonomous organizations called CDOT, Center for Development of Telematics. They have created certain products related to quantum, using which you can encrypt certain communications based on the quantum keys. So those are already being done in India. Also, a lot of research are going on, and even the products are now becoming available. So maybe we will try to push these standards or these products onto 5G advanced and 6G technology going forward.
Thank you, sir. Thank you very much, sir. Clarifying many doubts.
Yeah. So, Dr. Rajdeep ji, what happened to your lab? Whether you have started rolling out?
No, sir. We have the boxes are closed yet, and they'll be coming, I suppose, and they'll open up the boxes. And because we have done the receiving on the boxes itself, so we don't know what is inside.
Right. So there is a list of equipment which was shared with all of you, that what it should contain. So if you have that, you can, you can understand what all is there inside. Anyway, so this will get installed. Any other institute have got the equipment, just like Dr. Rajdeep confirmed that they have got the equipment at least. Any one of you can confirm?
Yes, sir. Yes, sir. We also received.
Yes, sir. Bits Pilani has also.
Acha, Bits Pilani you have received. Okay, Bits Pilani you have received.
And yes, sir. We have received equipments today.
Which institute?
Vidranga Institute of Technology, Tumkur, Karnataka, sir.
Acha, Karnataka. Acha, okay. South also some equipment received. Good. So I saw North Amritsar received, South Karnataka.
So Cochin University also received, sir.
Pardon?
Cochin University also has received. Yesterday it came.
Cochin, that means South. Okay. Anyone from West side?
Andhra Pradesh, within 2 days we are going to receive, sir, from Bangalore.
Okay, that means South equipment are being supplied. Yeah. And North side, I only have one confirmation. I think two confirmation, one from Rajasthan and one from Amritsar. Any more confirmation?
Dr. Rajan Prasad, Central University, Pusa, Samastipur, Bihar. Today I have received.
Acha, Bihar also you have received. Great.
Yes, sir. Just 30 minutes earlier.
Very great.
In Jharkhand, BIT Misra, yesterday we had received the packets. In BIT
आप
Misra.
देख नहीं रहे BIT मिश्रा से संजीत जी?
जी, नमस्कार.
नमस्कार.
So yesterday we have received the packets. Relevant.
आप इलेक्ट्रॉनिक्स में हैं, किस में हैं?
जी, इलेक्ट्रॉनिक्स कम्युनिकेशन, EC.
Okay, electrical में there is one professor Prem Prakash, you know him?
जी, Prem Prakash ji, yes, he's there.
He is my younger brother.
Yeah.
You know?
Yeah, I know.
Acha, you know that. Okay. Good.
Ashok, sir.
Okay, so shall we close for today?
Sir, I have a question.
Yes.
Yeah, please.
Sir, actually, I was trying to open this 5gc.org website. So it was not. It was something else. Like it was some other consortium. So.
Okay. I'll just. So what I'll do, I'll share those URLs where you can find open source radio and open source code. Okay. So let me also look at that and share.
We need to have a Linux installed for that requirement.
You have to. On your PC, you have to create partition. If your PC is Windows, create a partition and have Linux in one part. We'll tell you that how to do that. So there are tools available. No, you may be knowing. Using that tools, you can have different kind of operating systems together, and then you can create a virtual box, and there you can install your 5G core. Mostly it will be Linux based, Ubuntu based. So you have to install the Ubuntu in one of the partition and then go ahead.
Okay.
Generally.
Excuse me, sir.
Yeah.
Sir, we are from Western Maharashtra region, and we still had not received any of the equipments. Okay. So which suppliers will be providing? Can you give us some light on that for our region?
Okay, maybe next time I'll be sharing one slide which vendor is there and maybe their contact number also for you.
And sir, apart from that, are you having one of the session as discussed with that previous Aditya College ma'am, which open source softwares will be also deployed in that lab and such things?
So that lab, I mean, they will be supplying as per the tender conditions, whatever was there. I was suggesting that you can even without that lab, you can have your own kind of a 5G lab environment parallelly so that you can do more experiments. So that was my idea to explain how you can install a open source core onto any hardware which you may be having. That is in addition to the lab thing, right?
What is the tender condition?
Sir, it's kind request to you if it's possible for you to share some open source resources related to that.
I will do that.
Okay, sir. Thank you.
I will do that.
Sir.
And as requested by Patel Saab, we'll be sharing those tender conditions also, which you can read. Maybe on that particular folder, where I have putting resources, I'll put some more documents related to this our project itself. Or I can give one small presentation and then share the document so it becomes readable for you.
Okay, thank you, sir.
Hello, sir. Hello.
Hello, sir.
Ji.
Ashok Kumar, sir. Good afternoon,
Ji.
sir.
Namaskar.
Myself, Dr. Saranam from MBM University, Jodhpur. We
Ji.
have received some documents, the equipments yesterday, and around costing around 19 lakhs or 78,000. So we have some routers and display. Some items are there in the list. So we have received some items, and we hope that all the items will be received in this month also.
Okay, great. Yeah.
Sir, hello, sir.
Yeah.
Sir, I am Dr. Mallikarjun VC from SIT Tumkur, Karnataka. We received the equipment, sir. And sir, what next steps are like? They are going to come and install the things for us, and
yeah. So they will visit and install. So what I would suggest that you please associate a few of your members so that they understand and all. So because later on it will be you who will be using. So associate someone, fellows along with them so that you know all the aspects of installation.
Yes, yes, sir. Thank you, sir.
Thank you.
Sir, if I want to take for my project separately the equipment, how can I reach to the vendor, sir?
Okay, so rather we have already said in our process that if somebody want to expand the supplied 5G network, you are allowed, and you can directly have relation with these vendors, or for that matter any vendor. So we'll be, I can share the contact detail of these guys. So currently, since they are into supplying 100 labs, so they would be so busy that they may not be able to interact.
We do have 100 labs, these things, sir. I will inquire with our dean because I didn't know that whether they received.
So
then we can use the same lab.
Yeah. So you are free to expand this particular supply network or enhance this supply network, or whatever. Based on the rates discovered by TCIL, or maybe you can have your own negotiation and try to do that.
Any additional research equipment we can put on the top of
Always. Yes.
Thank you, sir.
Thank you. So Madhukar, shall we close now for today?
Yes, sir. It was very good session, and thank you.
So we have also received few.
Okay.
Excuse me, sir.
Yeah.
So we have also received few equipment yesterday only.
Okay, great.
From JP Institute of Information Technology, Noida.
Acha, JP Noida, you have got the equipment. Okay.
Yes, sir.
Okay, so Ashish knows all the contact of the vendor. Ashish Joshi, you may be knowing, no?
Yes, sir. Alok Joshi, sir.
Alok Joshi. Ashish or Alok?
Alok Joshi, sir.
So he knows the vendor very well. So maybe through him you can speak to that when balance equipments are coming and all.
All right, sir. All right. Thank you, sir.
Yeah, thank you. Thank you. So thank you, everyone. Thank you so much for listening to me. And whatever I have promised, I'll try to fulfill as quickly as possible on the information part. Thank you.
Thank you, sir.
Thank you, sir.
Thank you very much.
Thank you.
Thank you, sir.
Thank you, sir. Great day.
Thank you. Bye.
Thank you, sir.
Thank you. Thank you, sir. Thank you.
Thank you.